use the second derivatives test to determine the nature of the function at its critical points. The function is f of xy equals xy minus 2x minus 2y minus x squared minus y squared. And what we mean by the nature of the surface at its critical point is we could have a local extreme, a local max or min, or we could have a saddle point, or possibly neither. None of these. So first, find the critical points. The critical points are where f sub x and f sub y are both 0. So f sub x is y minus 2, 0, minus 2x, 0. So f sub x is y minus 2 minus 2x, and f sub y is x, 0, minus 2, 0, minus 2y. So we have to set both of these equal to 0, and that gives us a 2 by 2 linear system. Let's move the constant to the other side. Negative 2x plus y is equal to 0, and x minus 2y is equal to 2. Move the 2 over, not 0. Equals 2. And in the second equation, we also have a 2 on the right side. So now to solve this system, let's multiply the bottom equation by 2. Negative 2x plus y is equal to 2. And 2x minus 4y is equal to 4. And then we'll add the equations, and the x's will cancel, and we'll get negative 3y equals 6, which means that y is negative 2. So now if we substitute negative 2 into either of the equations, so let's take the second equation here, x plus 4 is equal to 2. Subtract 4, x is equal to negative 2. So there's one critical point, and that is at x equals negative 2, y equals negative 2. So the critical point occurs at negative 2, negative 2. Now we have to calculate the discriminant, which involves the second derivatives of the function, and that's why we have the second derivatives test. That's a plural. We have 3 different second derivatives: the pure second derivative in terms of x, the pure in terms of y, and the mixed. So let's calculate these second derivatives. F sub xx, here's f sub x here, 0, 0, negative 2. F sub yy, 0, 0, negative 2. And f sub xy, 1, 0, 0. So 1 squared. And our discriminant is 4 minus 1, which is 3, which is positive. And a positive discriminant means that we have local extremes as opposed to saddle point. If the discriminant were negative, we would have a saddle point. Now, to determine the nature of the surface at the local extremes, we have to look at either f sub x or f sub y, f sub xx or f sub yy. F sub xx at the point negative 2, negative 2. Well, f sub xx was always constant, negative 2. So that's negative, so we should be thinking concave down. And when you have a concave down function, then at a critical number, you have a maximum, a local maximum. This is the one variable case. And the result is the same in the multivariable case. So this is negative, and that means that we have a local max at our critical point, negative 2, negative 2.